Kind of feel like the Chapter 4 practice test isn't that hard, and it shouldn't take that long, so I'm really hoping for some good test scores on this test. The first problem has 4 parts, and it just really wants me to get used to just dealing with function notation. For part A, I'm just going to take the symbol g of x and replace it with what it's equal to and solve for x. And that's just like a beginning algebra problem. So this just wants me to solve 5x plus 20 equals to 0. I'm just going to solve it for x. I'm going to minus 20 from both sides, and then I'm going to divide by 5. And that's going to give me negative 4 for an answer when I eventually get it done. So after I minus 20, I've got 5x equal to minus 20. And then I'm going to divide by 5, and I'll get x equal to negative 4. So for my answer, it would be nice to see the x along with the equals. Very Christmas colors here, because it's just like the 2 days after Christmas. Question part B just wants me to take the f of x function, which is negative 2x minus 6, and replace it with the f of x symbol, and solve for x. This problem, because it has an inequality, I have to be careful that I change the direction of the inequality if it needs to be changed. And an inequality needs to have the sign flipped if you multiply or divide by a negative number. And that's what I'm going to have to do as I'm solving part B. So I'm adding 6 to both sides to get the x close to being isolated, and then I'm dividing by a negative 2. And you always flip or change only, I'll say only when I divide by a negative. Technically, you can multiply by a negative number and flip 2. It's really multiply or divide, but for us, we usually have to divide to solve for x. So I'm about ready to write an answer. And I have to really clean this up nicely. On the left-hand side, the negative 2's cancel. They leave me with the x. Because the number I divided by was a negative, I'm going to change the greater than sign to a less than sign. And on the right-hand side, that fraction reduces to negative 3. Adding and subtracting never cause the inequality to flip. It's only dividing and dividing by negatives. Part C, same sort of deal. I'm just going to replace the f of x and g of x with what they're equal to and solve for x. So I'm going to take the negative 2x minus 6 and replace it with the f of x. The 5x plus 20, replace it with the g of x. And I'm going to solve for x. Maybe I'll get the x's on the left side because that's where most students tend to get them. So I'll minus 5x from both sides. On the left-hand side, the x's both have negatives in front of them. I'm going to add the negatives and keep them negative. On the right-hand side, I force the x's to cancel. Now I'm going to add 6 to both sides. On the left-hand side, the 6's will cancel. I'll be left with the negative 7x. On the right-hand side, I have 26. Now I'll just divide by negative 7. On the left-hand side, the negative 7's cancel and give me the x. And on the right-hand side, I have a fraction that would be okay to write in my answer. I could write 26 over negative 7 in my answer, but that looks odd to me to see the negative in the denominator. I can move that negative up to the numerator, or I could move it out in front of the fraction, or if it didn't bother me in the denominator, I could have left it in the denominator. So my answer is some form of 26 over negative 7. You could have written that with an x equals, or you could write the negative in front of the fraction. Any one of those three would be fine. This is one I just instinctively would write. Part D has an inequality, so I have to be worried about flipping the sign. On the left-hand side, for the g of x, I'm going to put the 5x plus 20. For all the parts of number 1, I'm just replacing the function symbols with what they're equal to, and then doing the algebra to isolate the x. For part D, I'm going to do similar algebra. I'm going to add 2x to both sides to get the x on the left-hand side. When I add the 2x to the left side, I have the 7x. Still have the 20 because I haven't dealt with the numbers yet without the letters. On the right hand side, I cancel the 2x's. I'm left with a minus 6. Now I'm going to minus 20 from both sides. On the left hand side, the 20's cancel. I'm left with the 7x. When you're adding or subtracting, you never flip a less than to a greater than. It's only when you're dividing by a negative. On the right hand side, these numbers are both negative. I'm going to add them and keep them negative and get a negative 26. And then I'm going to finish up by dividing by a positive 7. And because I'm dividing by a positive 7, I'm not going to flip. Adding and subtracting doesn't cause me to flip the direction of the sign, nor does dividing by a positive. Only dividing by a negative would cause me to flip the sign. When I simplify the left-hand side, I get my x. I'm not flipping the less than sign, and the right-hand side doesn't really reduce, so I'm just going to leave it at negative 26 over 7. And I'm going to call that my answer for part D. The next few problems are word problems, and they're not the worst word problems, and they should be exactly like the word problems we did earlier in the section. So problem 2 that talks about a school district purchasing new television, one's for each classroom for $25,000. It says after 8 years the televisions will be worth $1,000 and have to be replaced. And then the important comment, assume the relationship between the value of the television, the number of years in use is linear. And then it kind of tells me parenthetically, let X be the age of the televisions and let Y be what the televisions is worth. Because the relationship between the value of the television and the age is linear, I can create an equation of a line to predict the value of the TVs for every year that they're in use. In order to do part A, to write a linear function that gives the value of the equipment for, or the TVs for the 8 years they're going to be in use, I have to create 2 points. And each point's going to have the form. The X is how old the TVs are, the Y's are how much they're worth. The easy point is gotten from the second sentence. The second sentence says after 8 years, the TVs are worth $1,000 and they're going to have to be replaced. I'm going to write that as the point 8 for the age of the television and 1,000 for the value of the televisions. I'm trying to come up with a linear, an equation of a line in function form that predicts the value of the TVs for the 8 years they're in use. In order to do this, I need to have 2 points. The second sentence gives me one of the points. The first sentence gives me the second point, or the first point maybe. And the value for the first point is going to be $25,000. That's going to be the Y. The age is going to be the X, and because they're brand new, they're going to be 0 years old. So these are the 2 points that I'm going to use to come up with a linear function that predicts the value of the TVs. And to find a linear function, or which is just an equation of a line written in function form, I have to have a slope. The slope I'm going to do by taking the Y coordinates of the points, subtracting them in the numerator of a fraction, and the X coordinates of the points I'm going to subtract in the denominator of my fraction. And this is going to give me the slope of the line as negative 24,000 over 8, which is negative 3,000. And then once I have a slope, I'm going to use the formula y minus y1 equals m times x minus x1 to get an equation of a line in xy form, and then I'm going to change the xy form into function form. What I'm going to do for my x1, y1, and m is use the easier points. So I'm in for y1, I'm going to plug 25,000. In for x1, I'm going to plug 0. And in for m, I'm going to plug negative 3,000. I'm going to plug those 3 values into the point, into the equation, and I'll get my line that I'm looking for. I could have chose 8 for x1 and 1,000 for y1, and I'd get exactly the same answer, just the work would be a little bit harder. So let me go through and do that. I'm going to change y1 to 25,000. I'm going to change m to negative 3,000. Now I'm going to change x1 to 0. And on the right hand side, I'm going to simplify it. And this is just going to be negative 3000x because x minus 0 is just x. And I'm going to add 25,000 to both sides to solve for y. And I will have a linear equation that's technically a function without function notation that gives me the value of the TVs for the 8 years they're going to be in use. The instructions say come up with a linear function, which probably tells me that I should change the y to a function notation. And in the videos, I probably did something like this. I said that I changed the y to a v, and I changed the x to a t. I'm just going to transform the algebra answer into something that's a function answer, or something written in function notation. And this might be the answer I'd write on my key for problem 2a. I'll call this my answer. So the equation y equals negative 3000x plus 25,000. When I glance at it, I can't tell that the x stands for the age or time in years, and I can't tell that the y stands for the value of the TVs. Now when I transform the letter y and the letter x, this says the value with respect to time is negative 3000 times the time, which was the age in years, plus 25,000. This would be a better answer than that. If you gave this answer, I'd live with it, but it's not really written in function notation in the way the question was asked. I really wanted function notation. Now I'm going to use either that or that equation to get the value of the TV after 5 years. To get the value of after 4 years, to get the value of the televisions after 4 years, I just plug 4 in for t into whatever answer you chose for part A. So the value after 4 years is going to be negative 3000 times 4 plus 25,000. I think that comes out to 13,000, but I'm going to do it on my calculator. On my calculator, I'm going to go negative 3,000 times 4 plus 25,000, and it gives me 13,000. So my answer, I can say the value after 4 years is $13,000. Quite honestly, on my key, I wouldn't even write a whole sentence. The answer on my key is probably just going to look like a 13,000 with a dollar sign next to it. So you can certainly just write $13,000 to the answer to the part B here with a dollar sign, or you can write something that's kind of a sentence. Done with number 2, now we'll move on to number 3, which is a real similar question. It gives me some information and it wants me to find an equation of a line that models the information. So if I read through this, a real estate office manages an apartment complex with 1,000 units. When the rent is $900 per month, all 1,000 units will be occupied. However, when the rent's up to $1,100 a month, only 900 units will be occupied. Assume the relationship between monthly rent and the number of units occupied is linear. Again, that's that same sort of linear assumption that we had in question 2. Part A says write an equation giving the demand y in terms of the price p. Hint, create points in the form rent, comma, number of units rented. So let me do that. I'm going to create 2 points because I'm going to come up with an equation of a line, and I'm going to let the x coordinates be the dollar amount of the rent and the y be the number of units rented. I know that when the rent is 900, all 1,000 units will be rented, so x is our rent, y is the number of unit rented. However, when the rent is $1,100, only 900 units will be rented. I'm going to come up with an equation, 900, of a line that fits the data because the relationship between the rent and the number of units rented is linear. And the way the question was worded, it says write an equation given for this information. and it doesn't say write a function. Because it doesn't ask for a function, I'm going to leave the problem not written in function notation. In order to do part A, in order to get my equation, I first need to get a slope. And to get a slope, I'm going to call it m. I'm going to form a fraction, and I'm going to subtract the y-coordinates of the 2 points I created, which is 900 minus 1,000. Put that in the numerator of my fraction. And then in the denominator of the fraction, I'm going to subtract the x-coordinates of the points. This is going to give me negative 100 in the numerator, positive 200 in the denominator, and that fraction reduces to negative 1/2. Once I have the slope, I can use the y minus y1 equals m times x minus x1 to get the equation that I need. Maybe I might want to put different letters in, but as long as I understand that the x's represent the dollar amount of the rent and the y's are the number of units rented, I can live with x and y. Into this equation, for y1, I'm going to put 1,000 just because that's the first point, and usually y1 stands for the y-coordinate of the first point. And for x1, I'm going to plug 900, which is the x-coordinate of the first point. If, when you went to find the equation of the line, if you put 1,100 in for x1 and 900 in for y1, you'd get the same answer that I'm about to get. So now I'm going to do the algebra. Y minus y1 equals m times x minus x1. Left-hand side, I'm going to leave y minus 1,000. The right-hand side, I'm going to clear the parentheses. I'm going to go negative 1,000, negative 1/2 times x, and then negative 1/2 times negative 900. I know that's positive 450, but if you didn't know that, clearing the parentheses needs me to take negative 1/2 and multiply it by negative 900, and when I do that, I get positive 450 on the right-hand side. Almost have a suitable answer for part A. I just need to add 1,000 to both sides. And an answer for part A, the equation of a line that models the data is y equals negative 1/2 x plus 1450. I'm going to write that as my answer, and my hint was to change the price to P as opposed to leaving it as an X. It says make the demand Y, which is the number of units. I'm going to leave the number of units rented as Y. I'm going to leave the Y a Y, and I'm going to change the X to a P. And in my answer for part A, barely left myself any room to do that, I'm going to take that equation of my line, and I'm going to change the X to a P, just because that stands for the price, and it's going to make it so I don't mess up when I do part B and C. So I'm going to say the demand, the number of units rented, Y equals negative 1/2 times the monthly rent, the price, plus 1450. Done with part A, I'll move on to part B. Part B says use the equation to predict the number of units when the price is $1,400. To do that, I'll just plug 1,400 in for the price and get Y equals negative 1/2 times 1,400 plus 1,450. That's just taking that P and changing it to 1,400. I'll do this on my calculator again because it's just easier for me. So I'm going to go negative 1/2 times 1,400 plus 1,450. That's going to give me 750. The algebra comes out to Y is 750. And my answer is going to be 750 units will be rented when the price is $1,400. I'm just going to put 750 units for my answer instead of writing a whole sentence saying 750 units will be rented when the rent is $1,400. Last bit, part C, what price will cause 700 units to be rented? Into this equation, I'm going to plug in 700 for Y, which is the number of units rented, and get 700 equals negative 1/2 P plus 1,450. And I need to solve that for the price, and that's not so hard to do, although the fraction makes it not as nice. I'm going to start off by minusing 1450 from both sides. On the left-hand side, 700 minus 1450, I'm doing off screen on my calculator because I don't want to make a mistake. I get negative 750. On the right-hand side, the numbers cancel and I'm left with a negative 1/2 p. Last thing I'm going to do is divide both sides by negative 1/2. The right-hand side, I'm going to get p, which is the price. And on the left-hand side, I need to do negative 750 divided by negative 1/2. I can do that on my calculator. Go negative 750 divided by, and put negative 1/2 in a parentheses. And that's going to give me 1500 for the price. So the answer to part C is a price of $1,500 will cause 700. A monthly rent of $1,500 will cause 700 units to be occupied. And so my answer, I'm going to be lazy and just put a $sign just to know that that 1,500 represents money, and just put the $1,500 in my answer. I could have written something nicer. I could have said at a price of $1,500 per month, 700 units will be occupied, but I don't really need to do that for part C. So that's everything for question 3. Question 4 really is just a problem that could have been written, and I think it was written in the chapter 2 test. It gives me a function, f of x equals x squared, and it first wants me to find f of x minus 3 plus 2. Super easy to do that. To do f of x minus 3 plus 2, when f of x is x squared, I create a function. The x minus 3 is going to be in a parentheses with a square outside of it because the original function is has an x squared, and the plus 2 is going to go after the function. That's all there is to do for part A of number 4. Now I need to describe the transformation. I know that minuses inside a parentheses will take the graph and shift it right. And pluses after the function will move it up. So you should know what it takes to move a graph left and right, and what it takes to move a graph up and down. Done with part B, moving on to part C, I'm going to make a table of values and sketch a graph. Immediately, what I'm going to do is take the number that makes the parentheses 0 and plug that in the middle of my x column, and put a couple smaller numbers and a couple bigger numbers in that column of x's. And I'm going to be lazy and use my calculator to get the y's. So I'm going to, on my calculator, put this function, x minus 3 squared plus 2. I'm going to do a zoom standard. That's what the graph should look like. And I'm going to get the values for my table by just going second table. Next to y equal to 1, I get 6. Next to x equal 1, I get y equal to 6. Next to x equal to 2, I get y equal to 3. Next to x equal to 3, I get 2. Next to x equal to 4, I get y equal to 3. And next to x equal to 5, I get y equal to 6. So I have 5 points, and I'm just going to plot those points to sketch my graph. The first point I'm going to plot is the point 1, 6. When I'm graphing parabolas, a lot of times I just make dots for most of the points, except I usually label the vertex. So I plotted the point 1, 6, 2, 3, and now the point 3, 2, that's going to be the vertex. I'm actually going to write that point down just because that's a habit of mine. And then the point 4, 3, and 5, 6. So those are the 5 points, or the 6 points that I have here. I'm going to connect those points with a parabola, and I'll be done with part C. So this would be a reasonable graph for part C. Part D wants me to find the domain and range. Real easy to find the domain. The domain of any parabola is going to be negative to positive infinity. I could sketch out some work along the graph to show you that that domain is correct, but I won't. I'm going to assume that you got that from the videos earlier in the section. For the range, for this graph, I need to find the bottom y and the top y. The bottom y is the y-coordinate of the vertex, which is positive 2. Because that's a point on the graph, I'm going to put a positive 2 with a square bracket on my answer to the range. This graph goes up to the top of the y-axis, and the y-coordinate at the top of the y-axis is infinity. The end of my range is going to be infinity. So the answer to the range for part D of question 4, it's going to be 2 to infinity. All parabolas have domains of negative to positive infinity, so I didn't really do much work for that. The last thing I need to do is write where the graph is increasing and decreasing. And in order to do that, I'm going to take the x-coordinate of the vertex and put it on the x-axis of my graph. I'm going to put a negative and positive infinity on the rest of the x-axis, and I'm going to create intervals. The intervals I'm going to create are the one from negative infinity to positive 3, and an interval from 3 to infinity, and figure out whether the graph is increasing or decreasing in that interval. The interval from negative infinity to positive 3 represents that interval, and as I'm moving from left to right, the graph is getting lower, so that's going to be a decreasing interval. And the interval from 3 to infinity is that portion of the graph. And then in that portion of the graph, as I move from left to right, the graph is getting higher. So that's going to be an increasing portion for my graph. And now I'm about ready to write my answer to part E. In fact, I already have it there, I think. I'm going to say, in terms of my answer, the graph is increasing in the interval from 3 to infinity. And it's decreasing in the interval negative infinity to 3. And that's everything for problem 4 that we need for an answer. Just, I think, 3 more problems left. Problem 5 gives me a function that's not written in a very nice form, and it wants me to use completing the square to write it in standard form. This function, x squared minus 6x plus 5, is going to graph to be a parabola. And what I'm going to do is rewrite it in standard form by simultaneously, on the left-hand side, adding and subtracting the same number c. C is always the number in front of the x to the first power term divided by 2 and then squared. So the c that I'm going to add and subtract is going to be negative 6 over 2 squared, which is negative 3 squared, which is positive 9. So I'm going to simultaneously, on the left-hand side, add and subtract 9, which is the number that's going to help me get this equation written in standard form. Once I add and subtract 9 to the left-hand side, I'm going to factor the first 3 terms, and I'm going to combine the last 3 terms. Should be easy factoring for you. When I go to factor these terms, the first are a couple of x's because I need to multiply out to x squared. The signs are a couple of minuses, and the last need to multiply to 9 and add to 6. Technically, they multiply to 9 and add to negative 6, and 3 will do that just fine. And when I combine the 5 and the negative 9, I get a negative 4. So I almost have my answer to part A. I'm going to get my answer by rewriting the x minus 3 times x minus 3 as x minus 3 squared, and I'll leave the minus 4 alone. Last thing I need to do is sketch a graph and label the vertex. I'm going to be lazy and I'm going to use my calculator to get the table again. I'm going to change the sign of that number in the parentheses, put it in the middle of my x column, do a couple numbers smaller and a couple numbers bigger, and those are going to be my x's for my table, and I'm going to worry about getting y's here in a second. To make sure I haven't made a mistake, into my y1, I'm going to enter the x squared minus 6x minus 5, and into my y2, I'm going to enter my answer, x minus 3 squared minus 4. If when I hit my graph button I only see one parabola, my answer to part A is right. If I see two parabolas, I've made a mistake in part A. And I might have to tweak this window a little bit. Oh, I made a mistake. I'll be darned. Because, how do I know I made a mistake? Because the original graph, x squared minus 6x plus 5, doesn't look anything like the graph to x minus 3 squared minus 4. So what mistake did I make? I have no idea. So I started off adding and subtracting c. I figured out what c is, which is negative 6 over 2 squared, which is negative 3 squared, which is 9. I added 9, subtracted 9. I don't see a mistake. First function I entered was x. First function I needed to enter was x squared minus 6x plus 5. Second function I needed to enter was x minus 3 squared minus 4. If I entered the original function correctly and my answer to part A correctly, those graphs should look exactly the same. And now when I fix the equation that I entered in y1, I only see one graph. So I know I have the right answer to part A after I fixed my mistake. And now I'm going to get my table by going second table. Next to 1, I see a couple of zeros, so it's going to give me the point 1, 0. Next to 2, I see a couple of negative 3s. That's going to be the point 2, negative 3. Next to 3, I see a couple of negative 4s. Next to 4, I see negative 3. And next to 5, I see 0. So I kind of get two sets of y's because I have two equations in as opposed to one. But the y's are the same because the equations are equal to each other. So now I'm going to plot these points. So on the x-axis, I need the numbers 1, 2, 3, 4, and 5. And on the y-axis, I really only need 0, negative 1, negative 2, negative 3, and negative 4. I'm making my table of values. I'm going to plot the point 1, 0, 2, negative 3, 3, negative 4 is the vertex, so I'm going to label the vertex. I have a habit of doing that. 4, negative 3, and 5, 0. If you only make dots for the rest of the points and you just label the vertex, that's completely fine. So this would be an absolutely decent enough graph for the test. I've labeled the 5 points and I have shown the vertex, and I feel good enough about that so that I'll call that an answer to part B. 2 more questions and not a lot of work to do to get the answer to those 2 questions. Question 6 talks about a ball being thrown straight up into the air, and it gives me an equation for its height for the few seconds that it's traveling. It says the height of this ball is equal to negative 8t squared plus 20t, where the height's in feet, and this equation maps the height of the ball for the t seconds that it's been thrown. And it says if you want to do this on your calculator using a graphing window of 0 to 10 for the x's, 0 to 20 for the y's, it'll be fine. I'm going to do this just with algebra. Part A says how long does it take for the ball to hit the ground? To do that, you just plug 0 in for the height, which is the h, and solve for t. I'm going to get two answers, and one of them is going to be a fraction. In order to solve this for t, I need to factor out a common factor. I'm going to factor out a common factor of negative 4t. When I factor out a negative 4t, I'm going to divide that negative 8 by negative 4 and get positive 2, and I'm taking a t away. When I factor out a negative 4t from this, I'm going to take 20 and divide it by negative 4 and get negative 5, and I took the t away. Now I'm going to set the two factors, negative 4t equal to 0, and I'm going to set 2t minus 5 equal to 0. The negative 4t equal to 0, I'm going to solve for t by dividing both sides by negative 4, and that's going to give me t equal to 0. That says at 0 seconds the ball is at 0 feet height. The next computation I need to do is 2t minus 5 equal to 0. And to do this, I'm going to add 5 to both sides. That's going to give me 2t equal to 5. And I'm going to divide by 2. And that's going to give me t equal to 5 halves, or t equal to 2.5. This is another time where the ball is on the ground. Essentially, the ball does something like this. At 0 seconds, it's at a height of 0 feet. It goes up, and then it comes back down. And at 5 halves, or 2.5 seconds, it's hitting the ground again. My answer to part A is not going to be 0 seconds because it's starting at the ground. I want to know how long it takes to get back to the ground. My answer to part A is either going to be 5 half seconds or 2.5 seconds. So for 6A, my answer could either be 5 half seconds to hit the ground, or if I make that into a decimal, 2.5 seconds. Seconds to hit the ground. So the answer for part A of number 6 is going to take 2.5 seconds. I can't write seconds right now. To hit the ground. To do part B, when does it reach its maximum height? The maximum height of this is going to be at the vertex of the parabola that makes this graph of this, the path that the ball goes, and the vertex, so this graph looks something like this. The vertex has an x coordinate, and in this case the x's are times, and a y coordinate, and the y's are heights. So part B really just wants me to find the x coordinate of the vertex, because the x coordinate of the vertex of this parabola is the time where it reaches its maximum height. The equation of this parabola is h, the height, equals negative 8t squared plus 20t, and I can get the x coordinate of the vertex by using the formula negative b over 2a, and the a is the number in front of the square term, which is negative 8, and the b is the number in front of the first power term, which is 20. So the x coordinate of the vertex, which is the time that I'm looking for, I can get by using negative b, which is going to be negative and then 20 over 2a, which is going to be 2 times negative 6, negative 8. This is going to be negative 20 over negative 16. I don't really care to do that right now, so I'm going to go on my main screen and go negative 20 divided by negative 16. I could either say 1.25 or math enter or say 5/4 seconds. So the time that it reaches its maximum height, I can either say it's 1.25 seconds to reach its maximum height, or I can say it's 5/4 seconds, and I almost kind of like the decimal here. Last thing I need to do is find the height. And you get heights when you know times by plugging in the time for t, and it'll give me the height. So the maximum height of the ball can be found by plugging in 1.25 for the time. So it's going to be negative 8 times 1.25 squared plus 20 times 1.25. And this is going to give me the maximum height. That's the y-coordinate of the vertex, which is the maximum height of this ball. And let me do that real quickly. I'm going to go -8 times 1.25 squared plus 20 times 1.25. And that's going to give me 12.5 for the number, and the height is in feet. So my answer, the maximum height, is going to be 12.5 feet. It's everything for number 6 without doing the graphing strategy. If you liked when I did it in the videos with graphing better, you don't need to do the algebra strategy for any of these. If you can sketch a graph and interpret the answers from the graph, I'm completely fine. Problem 7 gives me some information about a ball that a baseball player hits. Essentially, a baseball player hits a ball, and at 1 second it's at 12 feet, and it goes up, 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 and it comes back down, I imagine. And I'm supposed to come up with an equation that tells me for how high the ball is for different seconds, for different times. And it says use a graphing calculator to come up with a quadratic function to map the data. So can't do this by hand. On my calculator, I'm going to hit my stat button, and I'm going to hit edit. And then if I have a list 1 and a list 2, I need to clear out any numbers in my list 1 or any numbers in my list 2. One way to clear out a list is just go next to each number in the list and hit delete. Another way to clear a list is to go to the top of the list and then hit clear and then enter. So you should get to your calculator to have list 1 and list 2 kind of empty. And then now in list 1, I'm going to put the x coordinates of the points are 1, 2, 4, and 5. So the x's are going to go, or the times are going to go in list 1. I'm going to go over to list 2 and type 12, 19, 27, and 28. And now my calculator is going to help me answer part A. Part A wants me to find an equation to give an equation to track the height of the ball. To do this, we did stat, over to calc, down to quadratic regression, and then we did second and 1 for list 1, comma, second and 2 for list 2, comma, and then we stored it in y1. So then we did, how did we do that? We did second and vars somewheres. It's been a while since I've done this. So we did vars, y vars, enter on function, enter on y1. And now when I hit enter, it came up with the equation that I need. The equation it says is y equals to negative 1x squared plus 10x plus c, and it tells me it fits perfectly. And if I peek at my y equals right now, it took that equation and put it in y1. So now I could hit graph, and it's going to graph the equation. And I told myself I should change this window before I graphed it. So it's going to graph the equation, and if I made the x min 0, the x max 10, the y min 0, and the y max 50, I'll see the path of this ball perfectly. Oh, I don't like what I have written there. I'm spacing out today. Let me look at that equation. It's plus 3. So let me slow down and write an answer for part A. So it says, part A says use a graphing calculator use a graphing calculator to fit a quadratic function to the data. I don't think this is woke up yet either. So I need to come up with an equation, and this is the equation that my calculator gave me. Negative 1x squared plus 10x plus 3. And if you wrote that for an answer for part A, that's completely fine. Although the instructions tell me to write a function, so I'm going to write a function. And I'm going to say the height with respect to time of this ball is going to be given by negative 1t squared plus 10t plus 3. This is a completely fine answer for part A. This is an equally fine answer for part B. Part A, my gosh. I think I'm not quite awake yet. I don't know, it's almost 7 in the morning. I should be pretty functioning, but I'm not. Part B says use the equation to find the maximum height. This one I'll do on my calculator for you. So you have a way to do this with algebra, which I did in the last question, or I can find the maximum height using my calculator. So if you want to, on the test for maximum heights, you can use your calculator. What I need to get is the y-coordinate of the vertex, because a maximum height is gotten at the vertex of this parabola. One way to get the maximum height is to use the negative b over 2a formula to find the x-coordinate of the vertex, and then to plug the x-coordinate into the function to get the y-coordinate. That's a completely fine way to do it. You can do question C exactly like I did question, or you can do question B just like I did question C of number 6, and you'll get the same answer that I'm going to get using the other strategy, which is the calculator strategy. The calculator strategy to find the maximum height is you have to go second and hit the calc trace key, go down to option 4 that says maximum, hit enter, and then use your trace arrow and trace off to the left of the vertex and hit enter. Then use your right trace arrow and trace off to the right of the vertex and hit enter, and then trace as close as you can to the vertex and hit enter. And your calculator is going to give you what the vertex is. It says the vertex is the point 528. 5 is the time where it reaches its maximum height. 28 is its maximum height in feet, and I could actually even see it, what happened to be there. So the answer to part B, the maximum height, is the y-coordinate of the vertex, which is going to be 28 feet. Kind of felt like I was stumbling today, like my words, I was kind of tripping over my words. So if you go through the video and you really don't like what I did, I can redo this video. I have a bunch of videos to do before the semester starts, so I'm not going to redo it today. I think it's kind of probably okay, at least enough for one semester. But if you really don't like it, let me know and I'll redo it.